Today we are here from Ericsson at the AWS booth to talk a little bit about the Agentic AI architecture, how we help operators move to the next level of autonomy from level 4 to level 5. One of the key capabilities that we have already launched out to the market is our RAP portfolio. As we know, the networks are getting very complicated in the modern telecommunication providers, and the current and existing tools that we have for network management are not cutting the purpose. So we need to make a transformational shift in terms of how we do network management, and Ericsson is leading that domain with the RAP portfolio. Some of the RAPs that we have launched out to the market are around cell anomaly detection, anomaly root cause explanation, anomaly general optimizer, uplink interference, as well as the 5G AAS active antenna systems. Having these RAPs is allowing us to move to the level 4 autonomy. They are excellent in the domains that they are optimizing, but to move to the next level of network optimization, providing the right quality of service, as well as keeping the cost low and manageable for operators, we have to go the extra mile. And this is exactly where we're applying the Agentic AI architecture. The Agentic AI architecture is surrounded by the agents that are superveiling all these RAPs that we talked about. More importantly, introducing the technology with generative AI for a supervisor agent, which is able to optimize and orchestrate the activities between the RAPs in order to look at the end-to-end network. So here we're moving from a domain-specific to an end-to-end architecture so that we are able to do things automatically for the whole network. What we call this the cognitive loop. There's a continuous evaluation of what's happening on the network on the cell level. Anything that is detected, this is where our anomaly detection is coming into play. So whenever there is any anomaly detected by the system, we are moving towards understanding what is causing that anomaly, basically moving from the problem to understanding the cause, and then trying to explain what is the cause and optimizing by closing the loop towards an automation. This is what we call the cognitive loop. We also have an actuation agent. The actuation agent is basically what is taking the optimization action towards the radio access network. More importantly, we have an evaluation agent. The evaluation agent is looking at potentially all the optimization needs by the network and evaluating, depending on the gains, based on the gains, whether we should execute on that intent or not. In case an intent is not meeting the required optimization needs, we are basically blocking that intent and prioritizing the other ones. So the whole flow starts from issue to detection resolution. We follow a three-path process. The first process starts with the anomaly detection. The anomaly detection is a very important step in order to understand the characteristics of the network and the behavior of the network. This is where we understand if there is any optimization need. Moving on to the classification, that is the essence of the large language models and the neural networks in order to be able to drill down between the millions of combinations of what is causing the issue. Once that is classified, we move to the root cause analysis to understand the problem. We realize these with two anomaly detector modules. One is on the cell anomaly detection to understand the cell performance, and one is on the uplink anomaly detection so that we are able to specify the issue on the uplink issues. Moving on to the optimization, that's the first level of optimization that we can do. That is a general optimization agent. And these optimizations can be as simple as changing a single parameter in the RAN that will anyway increase the performance. If there is an even more serious problem, we have specialized RAPs and agents that are able, for example, to look at the vertical antenna tilt, as well as the horizontal beam. We also have specialized agents and RAPs that are working on the voice quality, as well as the uplink interference for the signal optimization. Now, this is what we call the full loop. It is always running. It is always surveying the network to make sure that we are reaching the right level of optimization. How do we achieve this? The RAPs are the essence of the knowledge. This is where we put our deep telco knowledge with our AI models into the RAPs, the individual RAPs. Combining the RAPs and building on top of them a large language module, which is what we call talk to data, as well as a RAG access towards our documentation. Every single pair of RAP and RAG gets its own agent. So having this agentic architecture will allow us to basically focus on the individual problems. Now we want to automate to the next level. This is where we bring the supervisor agent, the generative AI capability of basically orchestrating these agents in order to allow the network to be continuously evolving in the right direction. This is a generative AI technology, so ultimately it will be able to make the right choices based on the target goal for the network. What do we want to achieve from the network? If you want to make sure that, for example, it's performing in a specific location or providing the right level of service, or if you want to make sure that there is no voice degradations and you want to put a threshold to that, then the supervisor agent will ensure that is the case. The collaboration here with AWS is essential because all the RAPs and the AI models that we are working on are leveraging the AWS capabilities from the building blocks on the Agentic AI capabilities, as well as scalability, performance, and of course the data encryption, which is optimal for our operators. I'm going to be presenting here a bit of a showcase on how the backend system and how the autonomous loop is working in action. We present this through a talk, what we call a talk to network interface, which is basically a chat interface, intuitive natural language processing. So on the right-hand side, we have basically, we assume that's the backend, the backend of the system, and we have here the questions. So if we can, for example, ask a very basic question: what are the top 5 issues in the network? This is a very simple question that the system should be able to handle. The system knows, the supervisor agent takes that question, it reasons and tries to understand which agents it needs to invoke. So here, for example, it invokes the cell anomaly detector. We can get a more complicated problem that we have to solve, a more complicated optimization problem that we have to solve. And for example, now that we understand that the main problem is NSA retainability, I'm asking the system, or I want the system to automatically tell what are the top 3 issues that are causing that, which are the affected cells, and ultimately, because we are closing the loop, we want to make sure that we get the recommended actions. So the system here, again, the supervisor agent takes the ask, which is now being a question or an intent. The ask is then the reasoning is done by the supervisor agent, and it's broken down into logical steps. The supervisor agent will reach out to the individual agents where the information can come from. It starts with the cell anomaly detector, moving to the root cause explainer, getting the recommendation from the optimization, and that's exactly what we call the orchestration between the different agents. And then we get the information. What's very important here is that the system is able to recommend what is the next best action in order to achieve that optimization goal. I would like to highlight some of the key benefits of Agentic AI in the collaboration between Ericsson and Amazon Bedrock, what we have measured from our exploration so far in the market. So the business benefits for the operators is that we can help operators achieve more than 30% engineering capacity, more than 80% faster analysis and decision time, because basically the systems are working autonomously, and we have more than 8% network capacity from spectral efficiency that can be delivered to some of the networks. When it comes to the Agentic AI benefits specifically, we talk about operational efficiency, we talk about intent-based network optimization, because here we are coordinating the optimization across different agents. We have the flexibility as well as the unified monitoring and control. In addition to that, this is where the combination of Ericsson and Amazon really starts to shine. We talked about the secure data protection. So AWS is able to provide us with and the operators with that, ensuring that the data is always secured. Performance and scalability. We want to make sure that these systems are always up. We are talking about autonomous systems, so they always have to be available. Simplification in terms of how the processes are being conducted, and ultimately the speed agility. This is where anything that AWS is able to provide from new technologies, we will also be able to uptake in our solutions. So in summary, we have to move from our autonomous journey. In order to do that, we have to adopt new technologies and automation. And one Agentic AI and the collaboration with Ericsson and AWS is one means of achieving that. Thank you so much.